Hey guys, let's take a look at a one sample confidence interval for proportions. Now, one thing that's really important is to note that proportions, no matter what, are always a z and never a t. Okay, so let's read this really quickly. It says a company claims that in 20% of their cereal boxes, there's a coupon for free French fries at a well-known fast food restaurant. A random sample of 70 boxes showed that 11 of them contained a coupon. Okay, so a couple of things. We know that this is a proportion. We know that this is going to be p hat because that's what the sample proportion is going to be. We know that it's going to be 11 over 70. Okay, so if p hat is 11 over 70, then q hat is going to be 59 over 70. Construct and interpret a 98% confidence interval. Well, for 98%, if you take a look at your chart, you could get 2.326. Some of you might just do 2.33, okay? But that's what that is. Okay, so let's first, this is two parts of the question. So first, let's construct and interpret a 98% confidence interval for proportions. We need to understand that all confidence intervals, whether it's proportions or average, requires three steps. The first step is conditions. And we know that in the conditions, the stem states that what's being chosen at random. That a random sample of 70 boxes, that the cereal boxes were chosen at random. Okay, that's your first step. Make sure everything's in context and make sure that you understand what's random. Second, we know that n is equal to 70. You cannot use the central limit theorem here. So we need np hat and nq hat to be greater than 10, both of them, or equal to 10, so we can assume that it's approximately normal. Well, np hat, n is 70, p hat is 11 over 70, so that's just equal to 11, or just the numerator, and 70 over 59 over 70 is equal to 59, and then you will write down that since both np hat and nq hat are greater than or equal to 10, we can assume the distribution is approximately normal, okay? Approximately normal, not normal, approximately normal. Now, sometimes you will have to write that we can also assume, let me just get a different highlighter, this 70. We can also assume that the company has 70 times 10 amount of cereal boxes. So that's one of the conditions. You don't really need it. These two are good enough. But if you want to just remember that, we have to assume that there should be 10 times the sample size, okay? So we're going to assume that this company, or any cereal, there's over 700 boxes of cereal. So that's step one. Now, step two is going to be our formula. So step two is our formula. So the formula for a confidence interval is always the same. It's statistic plus or minus critical value times the standard deviation of the statistic. Okay? So it's statistic plus or minus critical value times the standard deviation of the statistic. So this guy here is 11 out of 70. This guy here is 2.326. This guy here, remember, it's not 11. It's 11 out of 70. That's what p hat is. This guy here is 59 out of 70. All of this is over 70, and everybody's over the square root. Okay, so everybody's over the square root. Now, we just need our calculator. Okay, so let me remind you how to do the calculator. Let me get my yellow. You press stat. Now, remember, you have to go 7 or below for confidence intervals. You go to A. Remember that x has to be a whole number. So x has to be a whole number. That's the numerator. And then the denominator, 98%. Press calculate, and then you get this number here. And this number is a wide range, okay? Because remember, the more confident you are, the more confident you are, I'm just going to round here. The more confident you are, the wider the range is going to be. So 0.06 to 0.26. So we are, step 3, we are, based on these samples, based on these samples, we are 98% confident that the true proportion of cereal boxes, be as specific as possible, maybe of like this brand, that contains a coupon is between 0.06 and 0.26. Okay, now you're done with the confidence interval. So there's another part here, but before I do that, let me just re-emphasize. It's a proportion. There's no S and there's no sigma. Remember that if it's a P, there's no sigma or S in the equation. Use your formula sheet. Do you think that the company's making a false claim? So guys, what did they claim? They claimed that it was 20%. Do we think that they're lying? No. Okay, I need a pen. No, because 20% or 0.20 lies in the interval of plausible values. So they're telling the truth. It's somewhere between these two numbers. So 20.20 falls in this, and so therefore they're telling the truth, okay? So please take your time, try the problem, look at it, make sure you can do it by yourself, and thank you for your time.